So in this situation, we have sleds A and B connected with a rope with A in front of B. Sled A is pulled forward with another rope, and the tension in that rope is 29 newtons. Masses of A and B are 6.7 and 5.6 kgs, and the friction on A and B are 9 and 8 newtons. Calculate the magnitude of the acceleration of the two-sled system. This is simply just an F equals ma question, but we need to determine the net force to use that. The applied force is 29 newtons, but friction is acting opposite to those with 9 newtons on one sled and 8 newtons on the other sled. So really our net force is 12 newtons. The mass of the system will be the masses of the two sleds added together. So the mass will be 12.3 kgs in total. And the acceleration, we don't know. Can use F equals ma to find that. Substituting in. Dividing by 12.3, this would round to 2 sig figs. We get an acceleration of 0.98 meters per second squared. Question B, the tension in the rope connecting the sleds. This one is not so easily answered without looking at a free body diagram. So I'm just going to quickly sketch one out. If we have sled B here and sled A here, this is a more complex free body diagram than the ones we've looked at, simply because we now have two objects. So they're connected by this rope. We have normal force on both A and B. We have gravity on both A and B. We have an applied force of 29 newtons. And we have friction acting on both A and B. The friction on A is 9 newtons. And the friction on B is 8 newtons. So when I'm asking for the tension in the rope connecting the sleds, this is the rope connecting the sleds, we need to take into account all of the things that are acting on that rope. So what is acting on that rope? Well, that rope is getting pulled backwards by the friction on sled B. And it's also being pulled forward by the force on sled A, specifically the net force on sled A. Well, we know the force of friction on sled B is 8 newtons. And the net force on sled A is not the 12 newtons net force to the system, because some of that force is pulling sled A and some of it's pulling sled B. We need to determine how much of that force goes towards pulling sled A. And what we know is that F net equals ma. We do not know how much force is devoted to sled A, but we do know its mass. .6 kg. And I apologize if I've been saying sled A. I mean sled B. Acceleration of the system is 0.98 newtons. working that out, would give us 5.5 newtons of force that is going towards pulling sled B. So we can fill that in, and we get that the tension in the rope would be 13.5 newtons.